let's talk about one of my favorite topics, which is triplexers. And the genesis of this session really goes back to not long ago, just a couple of weeks ago, when Fred and Paul K1XM and Dennis W1UE were at HQ9X. And right after the contest, we're sort of sitting in the living room and we're talking about our observations about how the station played. And the recurring theme was, my God, we're talking about a station with a basic tri-bender and a bunch of verticals. There is really nothing special about it. However, what makes the difference is the use of a triplexer that turns the single tri-bender into a true honest-to-God multi-tool station. So I said, well, Fred, how about we actually do a session on triplexers? I'm a firm believer. Fred himself is the person that started, in many ways, the concept of the triplexers with the first article published in QST. And he quickly embraced the idea, and we agreed that we're going to do a session. So the way we're going to do this is fairly straightforward. I have a few slides, keyword is a few, that outline the background of what a triplexer is, why you would want to consider one, can do pay attention to it. I think you're going to benefit from one. And more importantly, how to integrate into the station. We're also incredibly lucky, or are we still lucky, or we lost Pavel? I did reach out to, yes, he is with us.
He's still with us,
reached out to Pavel via 6 Alpha Mike, who is one of the very active manufacturers of triplexers and bandpass filters. And at the end of this presentation, you will see I have quite a lot of his boxes because, again, I'm the end user. I'm the systems integrator. People like Pavel, people like Fred are the brains behind the technology. And any questions that you guys may have when it comes to the technology itself are better answered by those individuals. So Pavel, welcome to YCCC. I hope your dad's surgery went well. Very happy that you could make it. So let me start sharing, and I promptly lost Zoom. Where the hell did it go? Oh, there we go. Can you see my screen?
Yep.
Yes.
All right. Oh, wait, this is the last page, not the first one. Let's start with the basics. So the topic for tonight is the magic of triplexers. And even though I've been using triplexers for maybe 10 years at this point, I still find it incredibly fascinating how this technology works. I mean, think about it. You basically connect 3 radios to the same antenna and you start transmitting and they don't burn. It's really the part that totally mesmerizes my imagination. So why is it not going? So what are we going to talk about tonight? So again, very straightforward presentation. We want to cover the basic. What is a triplexer? Why do you want to consider getting one and integrating into your station? How do you go about choosing one? And last but not least, how do you actually integrate it into your station? So what is a triplexer? It's a fancy word, but at the end of the day, a triplexer really is 3 filters, assuming it's a triplexer, could be a quadplexer, then you will have 4 filters. If it's a diplexer, then it's going to be 2 filters. But fundamentally, you have a bunch of filters that separate the input or the output, depends which way you're using the device. It's a bidirectional. And at the end of the day, it gives you the ability to share the same coax, the same antenna, across multiple
I see.
radios. One of the interesting aspects of a triplexer is the really good ones also have traps to tune out the other bands. So I have given here examples. If you have a triplexer for 10 meters, it has traps for 15 and 20. So it's not only a filter, but it's also a trap. And the reason why these traps are placed is to achieve additional attenuation of the undesired signal or the band isolation. Um, so the basic question, what is it in for me? I will go back to Fred and the whole genesis. It all started with field day. Um, You have a bunch of guys that have a tri-bender they brought to the field. They want to share it across the different stations. Well, how do you do it? Well, the solution is a triplexer, right? But that was only the beginning. Since then, the concept has evolved. It has received a lot of attention and recognition and has been deployed in many different situations. I think for many of you, one of the greatest benefits beyond field day would be quickly transform your station into an SO2R station, right? You already have most of the components. You have the radios, you have presumably a tri-bender, you have the coax, you may or may not have an amplifier. So adding the triplexer and the bandpass filters is the extra step that will convert your station into a powerful SO2R station. And if you have bigger ambitions, it's a fairly straightforward and I would add fairly cost-effective way to scale into multi-op configurations. My station in Canada started as a single operator, one radio, quickly evolved into two radios without the use of triplexers. And by virtue of adding the triplexer and the bandpass filters, it really evolved into a fairly capable multi-op station. Reduces the need for multiple antennas, right? If you can share the same antenna, across many different radios, you need fewer of these antennas, and the consequences are quite important. It is fairly cost effective. You don't need an antenna per radio. You may need smaller towers in terms of wind load capacity or the ability to carry weight because you no longer have a forest of antennas that are stacked on that tower. And the use of tri-benders itself has many benefits as well. The antennas are smaller, right? And the typical tri-bender does not have the same physical size as if you were to have three separate antennas for those bands. You have greater reliability and simplicity by virtue of using a single coax and fewer connectors. Um, and something I consider a benefit, others may not, is the wider horizontal beam width of the antenna, right? These are not monstrous antennas. So they have 60, 70, 80 degrees of beam width, which is fairly useful in a contest environment. And of course, when you start stacking them, and we'll talk about stacking later, you have the benefits of being able to change the arrival angle based on how you configure the stack. And of course, you get the extra couple of dBs by virtue of having two of those tri-benders. Choosing a triplexer is fairly important. You want to make sure that you choose the right one. Power handling is the obvious one. And I would consider, I would specifically highlight the difference between regular CW and phone operations versus Rudy and FT8 and FT4. So those modes are taxing not only on the radio and the amplifier, but they really tax all the downstream components of your station which includes the triplexers as well as the bandpass filters. Some triplexers and bandpass filters do have additional fans that help dissipate heat. Personally, I have ordered everything to include fans because I'm a passionate Rudy operator. I don't necessarily care about any of the digital modes, but for Rudy, the extra fans, particularly at HQ9X, where you already have high ambient temperature, is very important. Return loss as well as SWR, I don't think they need a lot of explanation. You certainly want to have those, well, you want to have as high return loss as possible, which equates to low SWR, because you don't want to lose power in these devices. And loss of power ultimately means more heat, so that would contribute to additional overheating of these devices. Likewise, insertion loss, you don't want to lose any signal, especially when you have large runs of coax or hardline. Every single tenth of a dB matters, so you don't want to waste your power heating the triplexer on the bandpass filter. And last but not least, I would actually argue that this is probably the number one criteria, or at least this has been my number one criteria, which is the isolation between bands. If you go to some of the classics on managing intrastation interference, there's actually a book with the very same title. You learn that you really need about 100 dB isolation between bands and the radios for a full legal limit power amplifier and antennas that are in the vicinity of each other. You can certainly go for lower isolation if you start separating things, but let's be realistic. A lot of us are constrained in terms of space. And you can achieve this by the combination of the triplexer itself. You can see from the table, the typical isolation of a triplexer is between 30 and 40 dB, followed by a bandpass filter, which would be anywhere between 60 to 80 dB, and you're getting to 100 dB. However, and that's a very important however, if you have an antenna switching matrix, you begin paying attention to what is the isolation that the matrix provides. Not matrices are created the same. Some have isolation in the high 60s, low 70s range. Others are much better. But the salient point here is that this could be the weakest link in your system and can compromise the otherwise great isolation that you have built through the bandpass filter and the triplexer. So let's see what this looks like in a real station. I get a lot of crap from K1XM that I'm using my V3 station as an illustration here for how to integrate. But honestly, I didn't really want to get into the business of creating brand new diagrams from scratch. So please bear with me and don't think of a fancy station. Think of literally what's on the screen. So the classic implementation of a triplexer with a tri-bender is just what it says, right? You have the triplexer, which is connected to the tri-bender. You have then bandpass filters on the output that further filter out that particular band before it goes into the antenna switch. In this particular case, I'm showing a 2x6 antenna switch, and then goes into the two radios. You may remember that earlier I was talking about quickly being able to evolve the typical station that has a tri-bender and a bunch of other antennas into an SO2R station. This is what it takes. You add the triplexer, you add the bandpass filters, you keep everything else the same, assuming you do have it, and you immediately become an SO2R station. Fairly inexpensive investment compared to the alternative of adding more towers, more antennas, and so on. The remaining infrastructure, 40 through 160, is the same. You don't really touch it. Whatever you have there is unchanged. Now, you can also deploy a triplexer or maybe a diplexer to perhaps run only a single coax between the antenna switch and your antennas. But to me, that falls in the category of non-classic or a little bit more advanced use cases. So let me pause here and see if there are any questions so far.
I have a question.
Sure.
I noticed that you have two sets of bandpass filters. You have one between the radio and the amp, and then one after the 2x6 switch. Is this for more attenuation, for more protection?
Yes. And my thinking, right or wrong, is that the radio generates some undesired signals. And I really don't want those undesired signals to go to the amplifier and be amplified. So that was the original driving logic behind it. And then the secondary, going back to the matrix itself, right? That is the weak link in systems like this. I felt that the additional filtering can offer a little bit protection against any possible weakness in my switching matrix. In my case, the matrix manufacturer didn't really provide specific port-to-port isolation. We measured it. It looked very impressive on the VNA, but again, better safe than sorry.
Okay. And can I ask you which 10 to 160 bandpass filters are you using at your station?
So I'm using OM Power, and the only reason I'm using OM Power is because they know how to talk to my ICOMs, and they do band switching automatically. I don't need any external decoders. It's built into it. At HQ&IX, I used to use, what were they called? The Hamatian bandpass filters that I used to have in my previous station in Canada. They worked just as well. So I don't think you need to obsess yourself over the low power bandpass filters. Again, in my case, the decision was solely based on simplicity. I wanted a single piece of control cable going from the radio to the bandpass filter.
Thank you, Rudy.
And yes, they do provide amazing undesired band suppression. I'm very happy with them.
And those are 200-watt filters on the left side, by the way, and kilowatt filters on the right side.
There are 4,000-watt filters on the right side because, again, I'm a Rudy guy. I don't have amplifiers that can produce 4,000 watts, but I want to make sure that these things do last.
Yeah.
Hey, Rudy, I want to make a comment. This is Mark.
Sure.
Yeah, on the filter that you've got to the right of the 2x6 switch matrix, you say that's rated at kilowatt or 1,500 watt or 4,000 watt, I guess.
Yes.
I have a couple of Alpha 89s, and what I've discovered, I don't run triplexers, but the antennas are in close proximity, in some cases maybe 10 feet apart or less. And when I'm transmitting on one band, I'm actually, I can actually see the power meter or the power indicator on the other amplifier, flickering away, and in some cases making audible noises. It's like I'm driving some circuitry within that amplifier, not the amplifier I'm transmitting on, but the other one that's in the listening mode.
Right.
And I can imagine having the filters like you've got it described would probably eliminate that, that chatter. It's kind of a weird thing, and it's only in certain combinations where, say, my tri-bander in close proximity to my 40-meter beam or something that just get a weird thing going on, but not every condition. But I was just thinking that perhaps added filters probably would solve that problem too. I don't know if anybody's ever experienced that
It certainly would solve it, because when you think about it, the alphas or any other power meter really measures power in two modes: reflected power and forward power.
right.
So if you don't have the filters, you get a bunch of RF energy that comes from the other radio. So in your case, you have two antennas that are nearby. In my case, I don't have a second antenna, at least in HQ9X. I have basically two radios connected to the same antenna. So if you don't have the filters, again, it goes back to that book, the Managing the Interstation Interference. They run through the numbers, and yeah, those voltages can be quite significant. So Mark, you're spot on. I would certainly imagine um, the LEDs flickering.
Yep. Well, I see that. Okay, thank you.
Sure.
Yeah, in the early generations of that amp, it was tripping out on high SWR. We were experiencing that at K9RS constantly. It was horrible. The amp, we had perfect SWR on the band that amp was on, but somebody would transmit on another band, and the induced RF would cause our amp to shut off
Yep,
because
I
it
can
thought it
see
was a
that.
high SWR. Yeah.
Yeah.
It's 40 and 15 was the worst, and 80 and 22. But 40 is putting out a pretty strong signal on 21 megahertz, right? So
Right.
that's what happens.
Okay. Yeah. Interesting
MCW.
point.
Yeah.
I love this debate. Any other questions or comments? All right, so let's look at another alternative. I call it overachiever, and I don't know how common this is. I'm one of the guys doing this. I know that, what is it, 8 Papa 5 Alpha is doing it. Um, and I'm drawing a blank who else is doing it, but the very basic concept is really a paradigm shift around how you stack tribanders with triplexers. The common scenario is you have the triplexers and you have the stack matches um, after the triplexer going to the tribander. So you basically stack match, or you stack entire tribanders as opposed to individual bands. And one of my design principles has always been fewer antennas, less wind load, and so on. So I stepped back and I started wondering, well, how could I achieve this without adding more antennas? Because I did want to be able to stack per band. So it dawned on me that there is fundamentally absolutely no reason why I cannot do the stacking before the triplexers. And this fancy diagram basically means that the signal coming from each of the bandpass filters goes through the stack match. And the stack match works as a normal stack match, can send the signal to the top triplexer, which in turn sends it to the top tribander, can send it to the lower triplexer, and therefore send it to the lower tribander, or it can power both at the same time and feed both antennas. The beauty of this solution is, sure, you add two more stack matches, right? Because now you have three bands you're stacking, but you gain a lot more flexibility. And I've observed it in Canada. It really pays off because we may be working Europe on 10, 15, and 20 at the same time. But when you start playing with antenna selection, you realize that you need different takeoff angles, which is what stacking does for each band. So you may want to use only the top antenna at 105 feet on 10, but you might be better off using the lower one on the other bends or a combination thereof. And in my case, I also chose stack matches that have the ability to feed the tri-benders out of phase so that you can achieve really high takeoff angle for short distance contacts. So this is not a very common implementation, but it's very powerful, very flexible, and personally, I absolutely love it. Before I go with the red boxes, any questions on the basic concept so far? Stacking per band as opposed to per tri-bender? All right, I'll assume that it's clear. So you see those red boxes, they're labeled as T50. And what this stands for is a 50 ohm termination. So again, I am not the engineer here. Fred and Pavel are. They can certainly dive into the engineering details. But since a triplexer is fundamentally a bunch of filters, these filters need to be properly loaded to function as they should. So even in the classic implementation, every triplexer manufacturer tells you that the unused ports need to be properly terminated with 50 ohm resistors. So in plain English, if I'm only using 10 meters and I'm not using 15 or 20, and using means there is no radio connected to it, so they're kind of floating in the air, they need to be terminated. And up until recently, I chose to ignore that recommendation. It's not that I didn't believe in it, I simply didn't have a solution how to deal with it. We measured it and we found out that yes, it does make a difference. Now, it's not a night and day difference, it's between 5 and 10 dB. But in my book of dBs, every dB matters, right? So if I can achieve another 5 to 10 dB of band-to-band isolation by adding those termination devices or termination resistors, I would absolutely do it. So I designed little boards that I plan on implementing next year. They're pretty dumb. There is nothing special about it. Basically, unless the board is activated, and it's activated by the same control logic that selects the antenna, there's a little relay that closes the circuit and the triplexer is terminated. And if I do need the antenna, again, I'm selecting it, I power that termination device, and it removes the termination while preserving termination for all the other antennas that are not being used. Again, don't expect night and day difference, but we measured between 5 and 10 dB. It differs from band to band. So again,
what's the power handling of that device?
Well, I think I sized it for 5 watts, maybe 10 at the most. Remember, that thing does absolutely nothing. So if you're transmitting on 10, you want to terminate 15 and 20. So you can do the math. Let's say that you get 40 dB attenuation on 15. So figure out what is minus 40 dB out of 1500 watts, and that will give you the power rating for each of these boxes. It's not a lot.
Mm-hmm. Okay.
Good question, though. All right. Questions, or shall I continue? All right, so this is where it gets really crazy, and this is what my station in Canada looks like. So you can see that at the bottom, I have the classic. Whoops. I have the classic, which is I have a small tri-bander. I have an OptiBeam, which is connected to a triplexer, and then is fed into individual bandpass filters for 10, 15, and 20, and goes into the switching matrix. Originally, this was my in-band radio antenna, although still is. We found that it works phenomenally well, and very often it was used by the designated run station as well. I deliberately separated it to have its own ports on the switch, under the assumption that if it's an in-band radio, it needs the same bands need to be available to more than one radio. I could have moved that triplexer to the top and added a 3-port stack match, but that would have really killed the concept of being an in-band radio. And then going back to the previous conversation on the overachiever design approach, I do have what I already described. I have 2 triplexers that are powered by stack matches, and then they're filtered by high power bandpass filters for 10, 15, and 20. My station was designed from the very beginning as 3 radios that can function in any configuration you choose to. You can have all 3 radios as run radios. You can have 1 and 2 in-band or multiplier, whatever. How they're being used very much depends on the logger, as well as the control logic, which is done through Pulse K1XM MOAS box. So this is what it looks like physically. The top part of the plywood board is the overachiever configuration, and the lower part is the classic. There are a bunch of other boxes that are kind of not that important. The black box in the middle is the AB switch. You may recall here, I have a bunch of options to expand my 40 meter, 80, and 160 antennas. So this is what the AB switch does. And then the big boxes on the very left that are outside of the green area, those are the 40, 160, and 80 meter bandpass filters. But the core, which is the combination of tri-banders and bandpass filters, is around these, are inside the green boxes. There are some other options. Again, how you integrate triplexers into your system is pretty much up to your imagination and how much hardware you're willing to throw at it. You can have 3 radios, share 3 tri-banders dynamically based on which port they're connected to, or you can go really fancy and do what's on the right, which again is a very viable configuration. Basically, any radio can use any of the 3 tri-banders or a combination thereof. And by the way, going back to 8 Papa 5 Alpha, he is doing the overachiever implementation based on what I excuse me, what I saw in the 2023 Dayton presentation. I believe the presentation is available on YouTube as well. So if you watch it, you would notice that he's talking about how he's using triplexers, how he's using stack matches. He's using the 3-port stack matches because he has 3 tri-banders, but fundamentally it fits in the overachiever design implementation. So as Harry reminded us, what really matters is the money. So show me the money. CQ Worldwide CW is a week from now, so we don't really have any data from it. But I quickly went back to last year's results in the multi-tool category because I felt it was quite relevant, right? We had 3 stations that are using tri-benders, and for the most part, just wires and verticals. So I would certainly draw your attention to HQ9X and VA2 Whiskey Alpha that did ridiculously high scores with very modest equipment. As a reminder, HQ9X is a tri-bender. That's it, with only 2 radios. And the Canadians have a little bit more hardware, both in the air as well in the station, but fundamentally, this is a station in a regular suburban division with not much land. Then compared to Whiskey 3 Lima Papa Lima that has acres and acres of antennas and probably 10 radios per band, look at the numbers. HQ9X did 10,000 QSOs and Lima Papa Lima did 8,500. So I think the numbers speak for themselves. Going back to my initial hypothesis, tri-banders plus triplexers are really game changers for small stations. I'm not saying it's cheap, but it is feasible. It is an affordable way to increase your capabilities, do better, and ultimately have more fun. XM3 Alpha, by the way, is my Canadian station. We didn't do so well, but it had nothing to do with the hardware. So there you have it, guys. Again, my favorite topic. More importantly, we really have the experts here. This is your opportunity to ask any and all questions from Fred or Pavel, VA6 Alpha Mike himself.
Excellent. That's great. Great presentation, Rudy. So I have a question or two. The tenor matrix switching, are those MOAS switches or are they something else?
So there are 2 components. There's the relays that do the switching. That's OM power. So my station is OM power.
Okay.
Bandpass filter, low power bandpass filters, power amplifiers, and the antenna switching is all OM power. And then the brains of the actual switching is MOAS. So we have a little MOAS client running on each computer that we use to select what antennas are available for each radio for each band.
I'd like to go ahead, Rudy.
So it's totally automatic.
I'd like to address something that Rudy said earlier, in that hopefully you can get 100 dB of filtering, and yes, you can do that. Unfortunately, most of these switches are limited to 85 dB on 10 meters, and a little bit more than that as you go down in frequency. But I just wanted to run an idea by everybody here and show you what I have been doing in order to make that even better. My thinking is that if you really want more isolation, you need to put more relays in series. And one easy way to do that is to have a relay that's on the output of the amplifier and another set of relays at the input of the amplifier. That way the gain of the amplifier does not have to go through both switches. And now you can, let's say you get the gain of the amplifier is 15. If your antenna switch has 15 dB gain, you can end up with 100 dB gain in the return path, which is where you need it. And I'll show you what that looks like, because this is what I've done on 6 meters. This is the output matrix, and this is actual conventional coax switches, 2 of them in series, each of them rated at 120 dB or 60 dB of isolation. 2 in series gives you 120. And then here is a second matrix, which is the input matrix, and these are all BNC connectors, and this is all wired up, and it's controlled by the PTT lines of the various transmitters that are going into this, and it pulls in all the relays, very much like what the MOAS does. But that's one way to get more isolation than what you can do in today's technology.
I've got a question for you, Fred.
Sure.
In the last week or so, we had conversation on Groups IO about injecting stubs. Reminded me of the old days, and and TT, or was it KY1H, K1TTT, Dave came up with some schemes, and you were probably behind some of that, I'm guessing. But is it possible to inject the stubs into these filter scenarios and achieve some higher levels of isolation and the numbers we're looking for? Or where do you see stubs having a play in here, if at all?
Yeah, I'll address that in two different issues, because in terms of trying to get to 100 dB, stubs is a very, very good way to do it, help you do it. Your filters are not that good. And I do want to go back to your old situation where you were talking about the getting SWR on a second station when you were operating at a different band, and stubs completely fixed that problem. And I'll go back and I'll address the issue as to why I came up with stubs. In the early 70s, I ended up buying a Signal 1 CX7. I thought it was going to be a wonderful radio, but it had a lot of shortcomings, and one of which is that it transmitted broadband noise and its receiver wasn't that good. And in order to help run that rig in a multi-station, I came up with the idea of doing stubs. And I did that in the 70s, and it was ultimately published in the Yankee Clipper Scuttlebutt in 1984. And Dave took that information and ran with it, and started doing some measurements and some fancy movements in order to try to get the maximum out of stubs. At the same time, Jim Lawson had been doing work on filters, and the filters are actually much, much better than stubs because they have more isolation and they have a broader frequency range. I actually brought something here just to show it. This is a filter that Jim Lawson had built, and this is one of his prototypes. I don't have the cover off on it, but it's basically a tune circuit on the input, a tune circuit on the output. There are parallel tune tanks there, and then another series tune tank in between it. So this becomes a pass reject filter. But this one happens to be 20 meters. And one of the things that Jim did, which was very interesting, is he did some measurements and some theory as to what's the best impedance to go into this, and what's the best impedance to go out of it, and what's the best impedance to couple between them, and how to get the loss low and everything else. So this thing has got some very, very interesting caps on the input filter. The actual impedance between the two of the filters is much higher than 50 ohms. That one I think's in the neighborhood of 1,000 ohms or so as the impedance in between it. So it's and then the coupling in between it is a lower impedance than 50 ohms. So one's at like 30 ohms, and the coupling in between it, coupled in at 50 ohms, transformed up to 1,000, and that's how Jim got a fair amount of loss or rejection in his filters. And nowadays, that whole filter is this. This is a Hamation filter. This is $129, and it blows away Jim's filters. And I wanted to show this because, Rudy's doing this all at high power, and not everybody in the club is going to be running high power. A lot of people might be running just A power, and these $129 filters will do just fine. And the filters themselves, the triplexers are expensive and big, and I just wanted to show you, this is a triplexer that I built. I built this for field day, and it's based on the design from the QST article that was done 20 years ago or thereabouts. And there's a little bit difference between what they did and I did. I looked at their design, and they had the common point. All the capacitors were connected to the common point. Well, guess what? The common point has all the voltages across those capacitors, so they had to be triple spaced. So I couldn't quite afford triple spaced capacitors. So I put the inductors on the common point, and the capacitors are on the outside, the individual bands. And I put it into a paint can because the paint can was a nice cheap piece of metal for it. And I found I had a lot of coupling between the inductors. So the 20-meter coil is actually wound on a toroid. And we use this on field day. And in June, we actually put up stacked tri-banders. And this is a little stack match I put together just for two tri-banders. It's the FT243 core in it, and it's just number 14 wire, 3 turns, tri-filer wound, and basically allowed us to take a pair of 1,200 watt TA33 juniors and run three bands into it on field day simultaneously. Interesting thing about field day is that field day gets really interesting nowadays because you can now have phones, CW, and FT8 on the air all simultaneously. And been working on ways to get CW and FT8 running on the same bands. And it's by careful selection of locations and by using some very, very high-end radios that are low in phase noise and good on third-order IMD and receivers. We can operate maybe 20 kilohertz apart on 40 and 20 and things like that, and actually do CW and sideband simultaneously, or CW and FT8 simultaneously.
Okay. I will offer a different perspective on stubs, which is something we did at HQ9X. And for those of you who don't know me, you have to take a look at my tower foundation in Canada that resembles a helipad. And my strategy is to over-engineer everything. So the reason I chose to implement stubs at HQ9X has nothing to do with the additional isolation between bands, right? Between the high power bandpass filters and between the triplexer, I felt that there is plenty of isolation. However, my concern has always been that there is leakage that is happening outside of that chain of triplexers and filters and switches, and some RF could be getting directly into the transceiver. So we actually installed stubs at the base of the 160, 80, and 40 meter verticals to make sure that extra energy on undesirable bands doesn't get transmitted and therefore go back into the radio, again, outside of the normal chain of filters and so on and so on. So that's another consideration. Fred and I are actually going to Canada next week, and one of our objectives is to figure out how much this leakage is happening. Am I being paranoid, or it's a real thing? And I think that could be another input into making the decision, add stubs or not.
You're talking about a quarter wave stub shorted at the far end?
Yep.
Okay. That does also lightning protection as well. So it's a big benefit.
I agree. I agree.
All right, guys, don't be shy. You have two esteemed engineers here. You have Fred, you have Pavel. This is your opportunity to learn anything there is to learn about filters and triplexers and anything else.
Without any questions, I'm going to go into a little bit of the traps you can get into with triplexer design, and that is that when you start putting amplifiers together, the power does not add linearly, it adds geometrically. So therefore, two amplifiers, each running 1500 watts, puts out 4 times that as peak power. And 3 transmitters operating simultaneously puts out 9 times that, which means that, let's say you've got 3 rigs running 1500 watts into a triplexer. Now you've got, let's see here, you got 13.5 kW peak power coming out of the triplexer. You're getting very, very close to the power handling capacity of RG8. If you look at LMR 400, for instance, it's rated at 16 kilowatts of peak power, not average power, but peak power. And with Rudy's RTTY duty cycles, that starts getting very, very, very close to being hairy. And just to give you some idea of scale, I did do a triplexer for TV. I specified it and we installed it in 2003. And this triplexer is designed to add 3 UHF TV channels together. Each input is a 6-inch cable. The output is an 8-inch cable. The average power coming out of the thing is 100 kilowatts on UHF TV, and it goes up the tower in one 8-inch line. And this has the same effect on TV that Rudy was talking about earlier. when you have one 8-inch line going up the tower, you have the lowest loss possible in one 8-inch line, but you have the benefit of feeding 3 stations into it. So from each station standpoint, each station has the benefit of having 8-inch line. So it has a lower loss than it would if it had its own 6-inch line going up the tower. So you have a wind load advantage, you have a lower loss advantage, you have a lower cost advantage. Same thing in television as you do in ham radio.
I have another question for you, Rudy. So basically, my question is if you have 2 radios running simultaneously in a contest and 2 separate operators, aside from maybe N1MM allowing, let's say, station B to know what station A is doing, let's assume that that's not built in. What prevents station B from tuning into the same band while station A is transmitting? So like this is the issue that we're trying to figure out right now for the club station to improve our score. We want to add a second station, but of course we don't have any of the triplexers right now or bandpass filters set up. So we're just trying to figure out what would happen or how do we prevent station B from band switching to the same station that station A is transmitting on.
So there is the classic solution and there is the overachiever solution. The classic solution is you buy an off-the-shelf switch that has the smarts to prevent what you just described. So if you look at the Hamation switches, they do that. If you look at the 403A switches that Flex is selling, those are fairly standard 2x8 switches that have the control logic built into them. So you get one box that does everything you want to do. Things get more complicated when you have multiple antennas per band, and therefore you cannot apply simple logic. On 80, I'm going to connect to port 3. On 10, I'm going to connect to port 7, and so on. So in those instances, you start looking at the overachiever type of systems, and fundamentally, they are 2 separate systems. You have the switching matrix, which you don't want to spend the money on a smart matrix. You want to buy something stupid, which is just relays. And then you add the control logic. So you can look at Green Heron everywhere. They do have the ability to control pretty much any switching matrix. You can look at what I'm using, which is MOAS by K2TR, which is infinitely programmable, which is both its greatest strength and weakness. But my gut feeling is that basically if you go with a basic Hamation box or 403 box, 403A box, you'll be just fine.
Okay, and I guess so. Would it work something like this? Let's station A is on 20 meters, station B goes to 20 meters, and it recognizes that there's already somebody on 20, so it cuts access to the port, to the antenna port. Would that be?
So the port will never. The port cannot physically be switched to 2 radios at the same time, right? The relay design behind it prevents 2 ports to be switched to, I mean, the same port to be switched to 2 radios. I think the benefit of the smartness is that the operator actually sees that the antenna is not available and they cannot select that antenna to begin with. But ultimately, it's how the switch is designed inside that prevents 2 radios to be connected to the same port.
Okay,
Yeah,
so it's the built-in protection. Okay.
Yeah. So
Thank you,
when
Rudy.
they go there to the same band, they're just going to hear just hiss, just dead silence, nothing.
Yeah, exactly.
Yeah,
I mean,
we're trying.
one of them is going to have antenna. The
Yeah,
first
whoever
one-
had it first,
Yeah,
usually.
We'll get the priority, right?
exactly.
It sounds. I know it. So listening to you speak about it, it makes sense now. But none of us have experience with setting up 2 radios in this fashion. So we're we're trying to figure. There's a lot of questions, right? We're trying to figure out how to go about doing this in the most, I guess, efficient and cost-effective way possible, right?
There's nothing cost-effective about this type of hardware. Let's be honest. So I would suggest you don't use this as a consideration. But again, I would encourage you to take a look at the 403A boxes. And I forgot what and the Hamation. They're fairly straightforward. This is what we use, for example, with HQ9X. Works beautifully. So it doesn't have to be fancy. And these are good boxes. They have good port-to-port isolation.
Okay.
May I add anything?
Go ahead.
Yeah, Pavel, go ahead, please.
There is a very standard approach to prevent this kind of switching to radios to the same band on a hardware level. It's called interlocking board that installed inside the switch. It's very simple. It's basically 2 small relays per band. And when you choose this one band, for example, these 2 relays block each other. So if another radio tries to switch to the same band, it's actually unconnected by the second relay, and it's physically not possible on the hardware level. And I personally use this approach, and many switches actually use the same. If you ask manufacturer, is there is any interlocking board, they probably reply yes, because it's the most reliable stuff. And another approach is on a software level. So if you build your station and you have both of them controlled by software and hardware, it's practically not possible to switch both radios or 3 radios to the same band and smoke some other radios.
So Pavel, like for example, if we're using 2 different flex radios, right, which is what we have right now at the station, are you telling me, aside from the matrix itself, that we can have both radios talking in a way so that one radio just physically will not go to 20 meters if the radio A is already on 20 meters? Is that what you're saying?
Yes, I'm talking about the antenna switch.
Oh, you're talking about the switch. Okay.
Yeah, because actually you can transmit on both radios at the same time, but it still should be some kind of switching between radios and antenna. So if you implemented this interlocking board inside your antenna switch, that physically it became not possible to switch both radios to the same band, and it would be protection. I have these boards for 2x6 switches. I'm talking about interlocking board, and it's basically I can ship it to you by cost like $3-5, and you can solder 12 relays inside, and it will be protection. You can add this interlocking board to your existing switch. But as I mentioned, lots of switches, 2x6 or 2x8 switches, they already got this kind of interlocking board inside.
Okay.
One word of caution, Shao, is do not rely on the logger to do the interlocking for you, because modern radios don't necessarily need a PTT activation to start transmitting. It can be over a cat command, could be simply holding the mic and activating it. So you really want to have the interlocking mechanism regardless of what software is running on your computer. Either the way Pavel described it, the hardware in the switch itself, or making sure you have a smart switch that does the locking for you. But
okay,
don't wait on N1MM to do it for you.
Yeah, that's like we're not at that point yet. I mean, we have the radios, we have the antennas. It's just basically coming up with the proper switching and bandpass filters at this point that we're trying to.
If you're running Flex, write the check, get yourself the 403A box. It works natively with Flex. You're going to save yourself a lot of headaches.
So right now we have a 4-band Yagi for 40, 20, 15, and 10. With 2 feed lines, one for 40 and then one for the higher 3 bands.
Right.
So I'm guessing this would take a quad, right?
No.
Instead of a triplexer.
No, you have a single band 40 and you have a tri-bander.
All on one boom. Yeah.
Yeah,
All
it
on
doesn't
one
matter.
boom.
It's all on one
Yeah.
boom or not. You have
So just
two antennas now, so you just need a triplexer.
So okay, and then just the BPFs, right?
Correct.
And four bandpass filters.
Yes.
Right. Okay. Okay.
And without triplexer, if you try to transmit on 40 and 20 meters at the same time, despite the fact that it's different coax lines, you still have to protect radios with some filtering. Otherwise, you can smoke it. Yeah.
Okay, so Matrix. Sorry, guys, I'm hijacking this this a little bit because we've been waiting weeks to have a discussion about this. But okay, so Matrix, BPFs, and Triplexer.
Yeah.
Okay, and then a lengthy phone call and email conversations with some of you gentlemen might be able to figure this out.
I've done exactly that. I'm going to jump in for a second too. KK1L. You know, I've designed a 2x6 switch, which some of you guys use. You know, it's not the most awesome isolation. Probably gets up into 75, maybe 80 dB in the best case. But I know Kirby's using it. He's on the call. I've just installed exactly the same thing that you're talking about, Dennis. I think it was where I've got a set of Pavel's bandpass filters for 40 and then 10, 15, and 20, and then the low power triplexer hooked up similar to what you're doing, but I've got a 2-element 40 stacked on top of a tri-bander. Works awesome. It's the best nearly $1,000 I've ever spent, quite frankly, is to set that up and have two radios going at the same time. But it doesn't take a lot of magic, and we can have a conversation if you want. I'm not as an expert as Rudy and Pavel and some of the others, but not a slouch, I guess. I could certainly help you out. But
so Ron, how much power?
I'm a low power guy.
Sorry, go ahead. Okay.
Sorry, I just wanted to throw in. Yeah, I highly recommend Ron's contest gear. His 2x6 switch is what Devin and I are using in our shack, and it works great. And Ron's support and help in building it has been just very generous. So yeah, just a +1 on Ron's the solutions that he's offering.
Yeah, it was a YCCC project from 15 years ago. Or more, it's been advanced since then, but anyway.
That's great.
Yeah, and I guess also another concern is we're running two alpha amps, so the isolation is going to have to be pretty good.
Yeah, but I mean, yeah,
don't want to experience any issues, right?
No, you're going to drop the. I mean, your cost savings. You know, you're once you go into the high power, forget about it. Right. That's not your consideration. You want to, it's cheaper than buying a whole bunch of antennas and having the power to support them, right? I mean, so you're saving money in that regard, but it's not.
It's also cheaper than buying new radios because you can easily blow the front ends if you're not careful and if there's too much interference between the two stations. So
yeah,
do it right from the very beginning.
Yeah. Well, thanks. I appreciate all the information, guys. Really, this is something that we've, me and a couple of the guys have been talking about for a while now. So this is it's been a very informative meeting so far. Thank you.
Well, if you're around next week, drive up to Huntsville. You can see things firsthand.
What's going on in Huntsville, Rudy?
Fred and I will be there and trying to figure out whether or not there is any leakage that is happening outside of the system of triplexers, filters, switches, and so on.
Okay, yeah, I'll probably send you. I'll send you an email later.
Sure. Okay.
Thank you.
Very good.
Great, lively discussion. Any other questions we can answer? Again, there is so much talent on this call. Take advantage of them.
Fred, I don't know if you caught that screen share of something you wrote a long time ago. I was going through some files today and I actually stumbled across that.
PJ8CO. It's in my
You're
log.
on mute, Fred. You're on mute.
As PGA-HCO was 1979.
Yeah, it's in my log. I have paper log. I remember it well.
All right.
Last call for calls.
Yep. Last call. Hope everybody's getting geared up for CQWWCW before Thanksgiving this year. So keep that in mind.
Remember, 10 minutes a day. That's all it takes.
That's right. All right. Everybody all set? We can wrap
Thanks
this
for this
up.
meeting.
Or yeah, it's getting late here.
Well, Harry and Pavel and Fred, thank you so much for contributing content and wisdom. Really appreciate it.
That was good fun.
I'll throw out one piece of wisdom that came to my mind. Sorry, during the demo there, it occurred to me, a lot of people maybe never thought about this before. I don't know, but the separation between two CW signals, they're X number of hertz apart, right? So if you have your side tone and your center frequency and your receive side at a lower frequency, so those pitches are low, then on a percentage basis, their frequencies are farther apart, right? As opposed to if you had it at a high frequency, like 800 and 850 are a lot closer together than 150 and 200, right? So maybe the 150, 200 is a little bit too low, but say 350 to 400 versus 850 to 800. It's a big difference in terms of on a percentage basis, and that's why if you have your side tone set to a lower frequency like 400 hertz or even a little bit lower if you can deal with it, you'll find that it's easier to separate the calls if you have multiple people calling you. As opposed to because naturally a lot of guys I've noticed when I sit down in somebody's chair or somebody's radio and listen in, it's like he's got his side tone at 800 hertz or 1,000 hertz. Like, really? I don't know. It's a personal preference thing. Everybody does their own thing, but what I've learned over the years is that it's easier to separate them if they're lower.
That's a really interesting point. I've always liked having the side tone frequency fairly low. I mean, middle C on a piano is not particularly low, and that's 256 hertz roughly. I've never thought about that, about how that spreads out the pileup. That's really interesting.
You know, there's another way to spread out the pilot. I don't know if it's doable with all radios that have two independent receivers. What I've experimented with my icons is I would actually enable both receivers and I keep them in tracking mode, but I would do two separate audio filters for each. So the one on the left would be only allowing, let's say for the sake of argument, from 0 to 400 hertz. Everything else is tuned out. So all these signals appear in your left ear. And then the right receiver, I would configure the audio filter to be the other way around, to be, let's say, from 400 to 800. So that really helps to spatially / physically / mentally, whatever word you want to use to describe it, separate the stations calling you in two separate ears. Really helps.
Well, that's a cool idea.
That's extremely cool. And you're going to get a perceived peak around 400 hertz too if you do that.
Exactly.
Which is pretty neat.
Yep.
That's a great idea.
Yeah, and I agree with you, and I've always operated that way with my side tone lower, but I've often wondered what happens if somebody calls me like 300 or 350 hertz low, and I never hear it because it's subaudible. Yeah. I just wonder.
Yeah, unfortunately that can happen. That's one of the downsides of it. It's true.
There is also less fatigue when you have your pitch lower.
Yeah, correct.
Yeah, I use
That too.
450 myself.
And also, as we get older, like it or not, we all lose our hearing from the top down, frequency wise. So eventually it'll become a matter of necessity to listen to the lower frequencies sooner or later. But
All right.
Good session, guys.
Yeah, excellent.